All right, I started recording. Let's hit it. Okay. All right. Welcome everybody to our December community call. And this is, I think, right around the holidays. So as expected, I think this one's going to be like short and sweet. And so we're recording this so that even if you're not able to catch up, you can catch it up later. And agenda for today, or we'll go over general updates. Um, we just released point 10 with a few really good features and some external integrations done. And we'll try to demo them over. So especially Kafka Connect, Ethan will be walking us through that. And DBT, Vinod, who's I think he'll be here. I think by the time we actually kick off the demo. And yeah, open floor Q&A. Point 10 is out, as everybody knows. It's a large release, packed with a lot of things. Test it out, give us feedback. And we have kickstarted a new minor release process with a point 10.1. So we'll be showing regular minor patches for the last major release version. That's roughly what we are looking at here. So this means the community has a regular stream of bug fixes delivered to you on top of the last major release. So test point 10 out and give us, file Jira's issues so that we can get them into point 10.1. Point 11 is already being planned and sometime in Feb. The main thing here is multi-model indexes and completing that and getting the query integrations all like, buttoned up, integrated, at least like Spark fully integrated for that. That's the goal here. And there's a lot more other things going on. Um, Gary's here. So the ByteDance people, they're contributing a bucketed index. There is record level indexes. There's from Uber. There's like many things um, that are being contributed at this point. There's also a large rewrite of data source v2. Um, that's another thing. With yeah, it's another minor thing. I think sometimes people on Slack are completely unaware of the mailing list. So we created this kind of like bot to keep syncing Slack conversations to those email threads to the dev work channel on Slack. So just so that you have one place to catch up on everything that's going on. And kind of like a self plug, but I think there's many times this has come up in the last few months is how we do concurrency control and how people are able to actually do things like async compaction while ingest is running and things writers are running, things like that. It's very different from what's out there. So, and I thought we wrote a blog to explain kind of how we think about it and what are the generally put in perspective what these data lake kind of concurrency control technologies have done in compared to, let's say, usual database warehouses. So worth the read for you if you just want to deeply understand what's going on. And broadly, I think it's about time we make a 1.0 roadmap, like clearly defined. We have the new platform mission that we kind of ratified last year. We should just like make a 1.0 goal towards which we can just like work towards this year and kind of like achieve that sometime. I think mid-year that'll be great. Okay. All right. We also have made a bunch of progress. So it turns out that on Presto, I think some of the Hive code has moved around and this has had some regressions around Hudi tables in the Hive connector. So we are almost resolved all of them. We just have the last PR, hoping that this gets merged once the Facebook folks are back from after the holidays. And we have the new Trino connector. There's a PR, this is the Hudi RFC. We are adding support for copy and write, MOR, RO, we're introducing a new connector now, because I think for Trino, they're like, oh, now let's create a new connector. That's fine. So we have the connector almost ready to go. We're hoping that we'll open the PR early next week against Trino. So if you can help test this, that'd be great. Yeah, this work is going on. As you know already, there's the three major things that we're adding. One is record level, like we're moving the Bloom filters to its own metadata table partition. Also adding range filtering for files and all of those things, and then another mechanism to track the record level index for the key. This work is going on. It's fairly voluminous kind of work. The way we are approaching it is we are also going to introduce like a indexer mechanism, like a new action through which the writers in the query can actually figure out what partitions are, index partitions are ready to be queried, what's being built and all of that. So there's fair amount of work here, but I think we're making decent progress towards that. I think support for Spark 3.2 was landed in master. So again, like if you want to test it out, give us more feedback, it'll be awesome. And I wish like Vinod was here, but I think we had starts and stops here, but right now, yeah, we adopted a model to make both BigQuery and Snowflake kind of like just plumbing it through to get them queried as external tables. So this will only support copy and write as external BigQuery Snowflake tables. And there's actually better ways to do it, except it costs a little bit more on the BigQuery Snowflake side. But I think we'll get to that eventually. So this is kind of work in progress still. It's just that we have more things to resolve, and we ideally want to make it work on both. Cool. So this week, this month showcases. I think there was a like a ByteDance talk with Presto and Hudi connector now, and I think we're trying to get more collaboration sort of like done, borrow ideas from that into the Trino connector and vice versa. But generally speaking, it's good to see that this sort of stuff is going on. So it's like augurs really well for the project. Amazon had a blog around comparing some of the performance features and all of that around clustering or metadata table listing, things like that. Just on TPCDS generally shows why these features should matter to you and what kind of benefits you can expect. On open source on point 10, we've actually gone a little bit, I think, past that. We are probably 6 months ahead at this point. Yeah, but generally speaking, it was like a really good, very, very well written blog, very detailed, went into a lot of like technical details. And I think GE wrote a blog again where they talked about their Hudi footprint and then their adoption of Hudi and how it was. It is a pretty successful story. I think 10,000 pipelines or something like that. So it's pretty cool actually that like Hudi is being used in very mission critical ways and very, very interesting use cases. And again, so we kick off the new year with an Uber Eng meetup. We'll have talks from Uber, Disney Hotstar, and then Walmart around their Hudi use cases. So if you're not aware of this, just please go sign up at Uber events, and it should be like a really fun talk, I think. Cool. With that, I think we just hand over to Ethan, I guess, for the Docker and sync. I can either do the slide things for you. You can just tell me next slide, or you can grab the screen. Either is fine. We can't hear you.
Sorry, I was on mute. Yeah, I can grab the screen, so I can do the live demo later as well.
Okay, sounds good. Let me stop sharing.
Cool.
I will make you host.
Cool. Yeah, let me share my screen. And yeah, there's one issue for sharing the screen. Yeah, let me rejoin the Zoom and share the
Yeah.
screen. Okay, cool. I think I need the permission to share the screen again. You know. Cool, thanks. Okay, now it works. So yeah, can you guys see my screen?
Yeah.
Cool.
Yeah.
Yeah, so so I'm a Hudi committer. So today I'm going to talk about the Kafka Connect sync for Hudi, which Rajesh and I built for 0.10 release. So let's first talk about what is Kafka Connect. So as you may already know, Kafka Connect is a free and open source component of Apache Kafka that works as a centralized data hub for simple data integrations between different systems, including databases, search indexes, and file systems like Hadoop, S3, and Elasticsearch. So it scalably and reliably streams data between Kafka and other data systems. To achieve that, Kafka Connect provides the meaningful data abstractions, the connectors, to pull and push data to Kafka. So you can define the connectors to move data into and out of Kafka's system. So there are two types of connectors. The source connector ingests the entire databases and streams the table updates to Kafka topics. And the second type of connector is the sync connector, which is the focus of this talk, which delivers the data from Kafka topics into the secondary indices or batch systems like Amazon S3, for example. So these provide a really convenient framework for people to ingest from the external data source and then ingest into external things. So why is Kafka Connect is concerned for Hudi? So let's first take a look at how Kafka records are ingested to Hudi before. So we have already provided the data streamer to ingest and stream records from Kafka to Hudi. So Delta Streamer is a standalone tool that can incrementally pull stream changes from different sources like DFS and Kafka, and then ingest them into Hudi tables. So users need to run the Delta Streamer as a Spark applications. So it requires a Spark engine. So in the 0.10.0 release, we added this new way of ingesting and streaming records from Kafka to Hudi via this Kafka Connect sync. So this offers like the flexibility for the current users of the Kafka Connect who already connect with S3, HFN, etc., to additionally sync their data to a data lake using Hudi. So this also helps users who do not want to deploy and operate Spark because Kafka Connect has its own cluster. It does not have to be depending on the Spark engine. So when we build the Kafka Connect sync for Hudi, we focus on the following key properties. So the first is that it guarantees exactly once delivery and no missing records, so that no deduplication is required. And second is that we make sure that all the async services, including compaction and clustering, can be scheduled in the Kafka Connect sync for Hudi so that they can be executed later. So when we build this sync for Hudi, we also make sure that it is centrally coordinated for the transactions so that it makes it easier to provide file management optimizations already in Hudi, such as the clustering and compaction I already mentioned. This makes sure that the target Hudi table's query performance is optimal, despite we are kind of using the streaming and incremental ingestion in this way. So currently in the 0.10 release, we only support the append only and immutable data from Kafka, but we are planning to get more to come in the future releases for the sync for different data types. All right, so let me go through the demo for the Kafka Connect sync for Hudi, and then we'll go from there. All right. So can you guys see my terminal?
Yeah.
Cool. So I've already set up the environment for the Kafka and the all the different things. So first I'm going to set up the Kafka topics and then push some messages there. So the parameters here is that I'm going to push 100 messages or records per batch every around 30 seconds, and there are 10 patches. And then basically I'll start the sync for Hudi using the Kafka utility. So once it's started, then I'm going to add this sync worker. So basically we can run multiple sync workers in either the standalone mode or cluster or distributed mode. So here I'm only running one. So I'm going to add this one to the connector list of connectors. So once it's there, basically the ingestion is going on. So now we can see that, so previously the table is empty. So now we can see that there's one in-flight delta commit going on. So we'll see how it goes. So while we are waiting for the result, we can check the config for the Hudi sync. So here are the basic configs. We have a few configs for the Hudi sync connectors, and then basically the Bootstrap server's location and the connector class, etc. And then below are the Hudi properties. So we read the messages from this test topic, and the table name is Hudi test topic. And then we are using the merge and read type for the target table. And then we also set the base paths, different properties, etc. So now I make the compaction, async compaction to for every 2 delta commits so that we can see that in a timeline. We can check. So now we can see that there's already 1 delta commit finishes. So we can also look at the commit using the Hudi CLI. So refresh. And then we can see there are 200 records written to this table. So after some time, we'll see the second commit in the timeline. And then, so right now I can also show that for the compactions, so currently there's no requested compaction. So once the second delta commit finishes, we should see 1 compaction here so that it can be executed later. All right, let's see. Still running.
maybe we can ask questions while it's running, Ethan.
Yeah.
Can you read from multiple topics at the same time?
I think for now, like we are only reading from one topic, but you can run multiple connectors to read from different topics.
Nice. And what was the concept of the workers again? I didn't fully get it.
Right. So basically, for each sync connector, you can have multiple workers doing the ingestion. So they all belong to the same like set of connector group, so that they can ingest the records in parallel. So in this demo,
Under the hood, are they actually separate Spark clusters, or is that like an inference of the parallelism within Spark itself, like if fanning out workers in Spark?
right. So for Kafka Connect, it does not use Spark. So it has its own, right. It has its own cluster. Right. So basically these workers are in the same cluster. And in Hudi sync connector, basically we have our own centralized coordination to coordinate the execution of these workers so that they work towards one commit as shown here.
So Connect is a distributed framework, and unlike Spark or Flink, there is no concept of a driver and an executor.
Okay, nice.
So
Right.
all you do is just like n workers, that's it. And then all of your HA, how executor goes down, the driver will respawn it, like that kind of like high availability is done by Kafka,
Nice.
the Kafka consumer library. So this is actually, even though the demo looks pretty simple, right? But it's non-trivial amount of work because you need to implement the driver executor model. So what we've done is exactly one of the workers will do the commit while we write in parallel. So we implemented some kind of distributed commit protocol here in order to do that. The reason again is that going back to concurrency, right? If you let each individual workers all commit directly to the table, if you are running 10 workers, you always have 10 concurrency to the table, right? And this is just going to be like pretty bad. It's going to live lock and cause a lot of other bad issues for us. So we try to avoid that completely in this design. And
right. Right. I think under the hood, basically we have these. So I think there's also like command to create this control topic. So we rely on this control topic to basically coordinate different workers so that they know like when to end the commit and when to start like writing new records. Yeah, that's happening under the hood. Okay, let me check.
The workers are also responsible for initiating the clustering and compaction, is it?
You mean for the worker or?
Yeah, so you mentioned that the compaction clustering will also be done. So the workers initiate them as well.
Oh, right. So the compaction and clustering are only to be scheduled by the sync connector. So for the execution, it has to be run later, like separately.
Gotcha.
Either using Spark or some other utility tool.
Okay, makes sense.
Cool. So yeah, so basically now there are 3 delta commits. We can see one compaction is requested. Can I refresh the timeline here? Yeah, basically you can see that a compaction is requested.
Yes.
And there are 3 delta commits now. All right, so yeah, so I guess that's it. So all of these demo can be run from the README on the Hudi Kafka Connect repo. So you guys can also try it if you want.
Oh, this is really, really, really cool. Thanks, Ethan.
Yep.
And I don't think we have yet for the no person. yeah, I don't think we know that for the DBT. I'll try to walk through it as best as I can, but I think hopefully we can have him like do a better one. So yeah, so recently we added support, we merged support in DBT so that you can author Hudi SQL kind of like pipelines using DBT directly. So since the real we know this in there, so I'll take over and try to do as much as I can around this. Yeah, so what is DBT? DBT is a transformation, like kind of like it's a transformation tool. Essentially, it lets you write your transformation in a declarative way, and then use SQL to author the pipelines, and you can set like many things like data quality checks and whatnot. It has different runners that you can run it on Snowflake, like or Apache, Spark, Databricks, anything else. Yeah, it's a simple tool that can best practices, peer reviews, like this whole bunch of like essentially takes the art of building data pipelines and kind of like provides a lot of support around that. It's like a really large community. It's like a company behind that now, so it's all going really good. And all right, so what did we do? As you know, typically Spark jobs, people use something like Airflow or like some like what is that, old older like Uzi, yeah, like something like that, right, to schedule your Spark jobs. So DBT, you can think of DBT as another option in that whole realm. This explains generally how people are using it. I think DBT can be used even for ELT use cases. And how we play here is so like we have plenty of tools to get from source to raw data, right? We already have Delta Streamer, and then Ethan just demoed one, which is the Kafka Connect tool, and the sync, which we're going to like do more. But then the idea here is, can you now write DBT pipelines to transform this raw data into more transformed Hudi data? That's where DBT comes in. And it essentially gives you portability across different environments, right? That is, so I guess like I didn't have a demo plan. So I'll probably just pass here. I would say, go check it out. It means it essentially should be able to write Hudi, DBT on Hudi like any other runner. That's basically how it is. We're going to be continuously improving it to a point where we can even do incremental ETLs and anything on top of this. With that, I think we're at almost the end of this. We can do like open floor Q&A, and then we can end. Since yeah, any questions from anyone? I see a new person here, Craig. Hey, welcome to the call.
Yeah,
and
thanks
since,
for letting me join. I'm actually just new to the whole Hudi topic, all in all, and just really just gonna try to come up to speed little by little, as my company has plans to potentially implement Hudi later this coming year. So, thanks.
cool. Yeah, I hope you're already on Slack and you are you know where to find. Otherwise, you can just ping, join Slack and ping in general. I think you'll get a lot of help that way.
Cool, thanks. I'm not, but I'll do that. Thanks.
Cool, that's good. Since we also have a lot of commuters on the call here, do you guys have any other technical topics that you want to discuss while we are all here? Anything that you want to like soundboard? Otherwise, we can just end early. This is like a pretty quiet call, given the time of the year. Right? Cool. Okay, good then. Hey Gary, nice seeing you again, man. Long time.
Yeah,
All right.
long time no see.
Yeah, I know. Cool. Very thanks everybody for making this call, and we'll make the recording available to everybody as well. And we'll do the repeat of the DVD in the next one in Jan. All right, sounds good.
Yeah.
Thanks, guys.
Thank you.
All right.
Bye-bye.
See you, folks.